Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P4 Variant 2 May-June 2022. Let's get started. Find the lowest common multiple of 30 and 75. First, we list the multiples of 30 and 75. From these lists, we see that the LCM of the two numbers is 150. Share $608 in the ratio 4:5:7. For the first part, we have 4 divided by the total ratio, which is 16 times $608. This gives us $152. Then we have 5/16 times $608, which is equal to $190. Then finally, 7/16 times $608, which is equal to $266. Work out 6.39 times 10 raised to the power 4 divided by 2.45 times 10 raised to the power 6. Give your answer in standard form. We can rewrite the given expression as this. The powers of 10 subtract. Since they have the same base and they are dividing. 4 minus 6 is -2. 6.39 divided by 2.45 is 2.61, rounded to 3 significant figures. So we have 2.61 times 10 raised to the power -2. Write 0.27 as a fraction. Let's call the recurring decimal x. When we multiply x by 10, this is what we have. And when we multiply x by 100, this is what we have. We see that x and 100x have the exact same pattern after the decimal point. So we carry them to the next step by subtracting x from 100x. This gives us 99x equals 27. When we divide both sides by 99, this is what we have. 9 goes into 27 3 times and goes into 99 11 times. So we have 3/11. A stone has volume 45 centimeters cubed and mass 126 grams. Find the density of the stone, given the units of your answer. The density of the stone is equal to the mass of the stone, which is 126 grams, divided by the volume of the stone, which is 45 centimeters cubed. When we type this into the calculator, we get 2.8 grams per centimeter cubed. The points P, Q, R, and S lie on a circle with diameter PR. Work out the size of angle PSQ given a geometrical reason for each step of your working. An angle formed in a semicircle is 90 degrees, so angle PQR is 90 degrees. The sum of the angles in triangle PQR must add up to 180 degrees. So when we subtract the sum of 29 degrees and 90 degrees from 180 degrees, we get angle PRQ to be 61 degrees. The angles subtended by chord PQ at the circumference must be equal. So angle PSQ is also equal to 61 degrees. The points A, B, and T lie on a circle and CTS is a tangent to the circle at T. ABC is a straight line and AB equals BT. Angle ATS is 98 degrees. Work out the size of angle ACT. Based on the alternate segment theorem, these two angles are equal. So angle ABT is also 98 degrees. Base angles in an isosceles triangle are equal. So when we subtract 98 degrees from 180 degrees and divide by 2, we get 41 degrees. Based on the alternate segment theorem, these two angles are equal. So angle BTC is also equal to 41 degrees. Angles on a straight line add up to 180 degrees. So to get this angle, we subtract 98 degrees from 180 degrees, which gives us 82 degrees. The sum of the angles in triangle BCT must add up to 180 degrees. So we have angle ACT plus 82 plus 41 equals 180. When we make angle ACT the subject, we get angle ACT equals 57 degrees. A line L joins point F with coordinates 3, 2 and point G with coordinates -5, 4. Calculate the length of line L. To get L, we apply the distance or length formula. This gives us L equals square root of -5 minus 3 squared plus 4 minus 2 squared. When we type this into the calculator, we get 8.25 rounded to 3 significant figures. Find the equation of the perpendicular bisector of line L in the form y equals mx plus c. All we need to do is find the values of m and c for the perpendicular line and plug in these values into y equals mx plus c. Before we get the gradient of the perpendicular line, we need to get the gradient of line FG. To get this, we apply the gradient formula. This gives us 4 minus 2 divided by -5 minus 3, which is equal to -0.25. The product of the gradient of the perpendicular line and the gradient of line FG, which we found to be -0.25, must be equal to -1. When we divide both sides by -0.25, we get m to be 4. Before we get c, we need to get one set of coordinates through which the perpendicular line passes. Since the line is the perpendicular bisector of FG, then it means the line passes through the midpoint of FG. To get the midpoint of FG, we apply the midpoint formula. So for the x-coordinate of the midpoint, we have 3 plus -5 divided by 2, which is equal to -1. And for the y-coordinate of the midpoint, we have 2 plus 4 divided by 2, which is equal to 3. So now we plug in the value of m and the coordinates of the midpoint into y equals mx plus c. This gives us 3 equals 4 times -1 plus c. When we make c the subject, we get c equals 7. So we have y equals 4x plus 7. A point H lies on the y-axis such that the distance GH equals 13 units. Find the coordinates of the two possible positions of H. We know the coordinates of G, which is -5, 4. We are told H lies on the y-axis. This means the x-coordinate of H is 0. We are told GH is 13 units. So by applying the distance formula, we have 13 equals square root of -5 minus 0 squared plus 4 minus y squared. When we square both sides, this is what we have. 13 squared is 169. -5 minus 0 squared is 25. And when we expand 4 minus y squared, we get y squared minus 8y plus 16. When we move all the terms to one side of the equation and group like terms, we get y squared minus 8y minus 128 equals 0. We can solve for y using the factorization method. We can rewrite minus 8y as 8y minus 16y. For the first two terms, when we factor out y, we are left with y plus 8. And for the final two terms, when we factor out -16, we are left with y plus 8. This can be rewritten as y plus 8 times y minus 16. When we equate y plus 8 to 0, we get y equals -8. And when we equate y minus 16 to 0, we get y equals 16. So the two possible coordinates of H are 0, -8 and 0, 16. ABCD is a trapezium with DC parallel to AB. DC is 6.4 centimeters, DB is 10.9 centimeters, angle CDB is 38 degrees, and angle DAB is 45 degrees. Find CB. To get CB, we apply the cosine rule to triangle BCD. This gives us CB squared equals CD squared plus BD squared minus 2 times CD times BD times cos of angle CDB. CD is 6.4 centimeters, BD is 10.9 centimeters, and angle CDB is 38 degrees. When we plug in these values into the equation and make CB the subject, this is what we have. When we type this into the calculator, we get 7.06 centimeters rounded to 3 significant figures. Find angle ADB. These two are alternate angles. Alternate angles are equal, so angle ABD is also 38 degrees. The sum of the angles in triangle ABD must add up to 180 degrees. So we have angle ADB plus 45 plus 38 equals 180. When we make angle ADB the subject, we get angle ADB equals 97 degrees. Find AB. To get AB, we apply the sine rule to triangle ABD. This gives us AB divided by sine 97 equals 10.9 centimeters divided by sine 45. When we make AB the subject, this is what we get. When we type this into the calculator, we get 15.3 centimeters rounded to 3 significant figures. Calculate the area of the trapezium. Here is the formula for the area of a trapezium. A plus B, which is the sum of the parallel sides of the trapezium, is 6.4 plus 15.3 centimeters. We need to find H. To get H, we apply SOHCAHTOA. This gives us sine 38 equals H divided by 10.9 centimeters. When we make H the subject, we get 10.9 sine 38 centimeters. So now, when we type this into the calculator, we get 72.8 centimeters squared, rounded to 3 significant figures. Draw the lines of symmetry of the rectangle. The line of symmetry of a shape is a line that splits a shape into two mirror halves. A rectangle has two lines of symmetry. Describe fully the single transformation that maps triangle A onto triangle B. When we look at triangle A and its image triangle B, we can tell straight away that this is a translation because both triangles have exactly the same size and orientation. The only difference is that they are located on different parts of the grid. So now all we need to do is to find the translation vector. From the illustration, we see that the translation vector is -1, 4, and so the full description for the transformation is translation by the vector -1, 4. Describe fully the single transformation that maps triangle A onto triangle C. When we look at triangle A and its image triangle C, we can tell straight away that this is a rotation 90 degrees in the anti-clockwise direction. So now we need to identify the center of rotation. For a 90-degree rotation, the way to determine the center of rotation is this. We draw lines to connect at least two corresponding points on both triangles. Then we draw the perpendicular bisectors of these lines. The intersection point of the bisectors is the center of rotation, which in this case is 2, 1. And so the full description for the transformation is rotation 90 degrees anti-clockwise about the center 2, 1. Draw the image of triangle A after reflection in y equals 2. First, we need to draw the line of reflection, which is y equals 2. Then we reflect each vertex on triangle A in the line y equals 2. This means if we pick point A on triangle A, since we move 3 units upwards to touch the line of reflection, then we also need to move 3 units upwards from the line of reflection to pin the new position of point A. After repeating the same process for all the vertices on triangle A, we are now able to map out the reflected image of triangle A. Draw the image of triangle A after enlargement by scale factor -2, center -1, 1. First, we need to mark the center of enlargement, which is -1, 1. Then we need to move each vertex on triangle A such that we are able to reproduce the enlarged image of the triangle. Let's pick point A. To move from the center of enlargement to point A, we move 2 units downwards and 1 unit to the left. The scale factor is -2, so to pin the new position of point A, we move twice the distance we moved initially and in the opposite direction. This means we are now going to move 4 units upwards and 2 units to the right. After repeating the same process for all the vertices on triangle A, we are now able to map out the enlarged image of the triangle. At a festival, 380 people out of 500 people questioned say that they are camping. There are 55,300 people at the festival. Calculate an estimate of the total number of people camping at the festival. If out of 500 people, 380 are camping, then we want to find the expected number of people camping at the festival, which has a total of 55,300 people. This is what we are calling X. When we cross multiply and make X the subject, this is what we get, which is equal to 42,028. 12 friends travel to the festival. 5 travel by car, 4 travel by bus, and 3 travel by train. 2 people are chosen at random from the 12 friends. Calculate the probability that they travel by different types of transports. One way we can go about this is to find the probability that the 2 friends chosen travel by the same transport and subtract from 1. The probability that the first person chosen travels by car is equal to the number of friends who traveled by car, which is 5, divided by the total number of people, which is 12. After this person is picked, the pool reduces by 1. And so the probability that the second person chosen also travels by car is 4/11. The probability that the first person chosen travels by bus is equal to the number of friends who traveled by bus, which is 4, divided by the total number of people, which is 12. After this person is picked, the pool reduces by 1, and so the probability that the second person chosen also travels by bus is 3/11. The probability that the first person travels by train is equal to the number of friends who traveled by train, which is 3, divided by the total number of people, which is 12. After this person is picked, the pool reduces by 1, and so the probability that the second person chosen also travels by train is 2/11. When we type this into the calculator, we get 47/66. Anno buys a student ticket for $43.68. This is a saving of 16% on the full price of a ticket. Calculate the full price of a ticket. If Arno is saving 16% on the full price, then we subtract 16% from 100%, which gives us 84%. So the amount Arno pays, which is $43.68, is 84% of the full price. When we divide both sides by 84%, we get the full price of the ticket to be $52. At a football match, there are 29,800 people. Correct to the nearest 100. At the end of the football match, the people leave at a rate of 400 people per minute. Correct to the nearest 50 people. Calculate the lower bound for the number of minutes it takes for all the people to leave. To get the lower bound of the time, we divide the lower bound of the total number of people by the upper bound of the rate at which the people leave. To get the lower bound of the number of people, we subtract 100 divided by 2 from 29,800, and for the upper bound of the rate, we add 50 divided by 2 to 400. When we type this into the calculator, we get 70. At a cricket match, there are 27,500 people. Correct to the nearest 100. Calculate the upper bound for the difference between the number of people at the football match and the cricket match. To get the upper bound of the difference, we subtract the lower bound of the number of people present at the cricket match from the upper bound of the number of people present for the football match. To get the upper bound of the number of people at the football match, we add 100 divided by 2 to 29,800, which gives us 29,850. For the lower bound of the number of people at the cricket match, we subtract 100 divided by 2 from 27,500, which gives us 27,450. This gives us 2,400. Information about the mass m kilograms of each of 150 children is recorded in the frequency table. Calculate an estimate of the mean mass. Before we get the estimate of the mean, we need to find the midpoint of the given mass intervals. So for the first interval, the midpoint is 0 plus 10 divided by 2, which is 5. Then we have 10 plus 20 divided by 2, which is 15. 20 plus 25 divided by 2, which is 22.5. 25 plus 40 divided by 2, which is 32.5. 40 plus 50 divided by 2, which is 45. So the mean is equal to the total sum of the masses of the 150 children, which is 5 times 12 plus 15 times 38 plus 22.5 times 32 plus 32.5 times 50 plus 45 times 18 kilograms divided by 150. When we type this into the calculator, we get 25.2 kilograms rounded to 3 significant figures. Draw a histogram to show the information in the table. To be able to draw the histogram to show the information given in the table, we need to calculate the frequency density for each of the given intervals. For the first interval, the frequency density is equal to the frequency, which is 12, divided by the interval width, which is 10 minus 0, which is equal to 1.2. Then we have 38 divided by 20 minus 10, which is equal to 3.8. Then we have 32 divided by 25 minus 20, which is equal to 6.4. Then we have 50 divided by 40 minus 25, which is equal to 3.33. Then finally, 18 divided by 50 minus 40, which is equal to 1.8. So now, after marking all the different intervals on the horizontal axis of the grid, we can map out their heights using their frequency density values. Use the frequency table to complete this cumulative frequency table. For m is less than and equal to 10, the cumulative frequency is 12. For m is less than and equal to 20, the cumulative frequency is 12 plus 38, which is equal to 50. For m is less than and equal to 25, the cumulative frequency is 50 plus 32, which is equal to 82. For m is less than and equal to 40, the cumulative frequency is 82 plus 50, which is equal to 132. For m is less than and equal to 50, the cumulative frequency is 132 plus 18, which is equal to 150. Calculate the percentage of children with a mass greater than 10 kilograms. This percentage is equal to the number of children with a mass greater than 10 kilograms, which is 150 minus 12, divided by the total number of children, which is 150, times 100%. This gives us 92%. Solve 10 minus 3p equals 3 plus 11p. When we group like terms, we get 14p equals 7. And when we divide both sides by 14, we get p equals 0.5. Make m the subject of the formula. mc squared minus 2k equals mg. First, we move all the m terms to one side of the equation. So we have mc squared minus mg equals 2k. When we factor out m, we are left with c squared minus g. When we divide both sides by c squared minus g, we get m equals 2k over c squared minus g. Solve 1 over x minus 3 plus 4 over 2x plus 3 equals 1. The denominator for 1 is 1. To get the LCM, we multiply the denominators, x minus 3 times 2x plus 3 times 1, which gives us x minus 3 times 2x plus 3. So now to clear the denominators, we multiply through the equation by the LCM, and this is what we get. When we expand the brackets, 1 times 2x is 2x, 1 times 3 is 3, 4 times x is 4x, 4 times negative 3 is negative 12, x times 2x is 2x squared, x times 3 is 3x, minus 3 times 2x is minus 6x, minus 3 times 3 is minus 9. When we move all the terms to one side of the equation and group like terms, we get 2x squared minus 9x equals 0. When we factor out x, we are left with 2x minus 9. So x equals 0. And when we equate 2x minus 9 to 0, we get x equals 4.5. Solve the simultaneous equations. You must show all your working. First, let's label the given equations. We'll be using the substitution method. When we make x the subject in equation 1, we get x equals 12 minus 2y. When we plug in x equals 12 minus 2y into equation 2, this is what we have. When we expand the brackets, 5 times 12 is 60. 5 times negative 2y is negative 10y. When we move all the terms to one side of the equation and group like terms, we get y squared minus 10y plus 21 equals 0. We can solve for y using the factorization method. We can rewrite minus 10y as minus 3y minus 7y. For the first two terms, when we factor out y, we are left with y minus 3. And for the final two terms, when we factor out minus 7, we are left with y minus 3. This can be rewritten as y minus 3 times y minus 7 equals 0. When we equate y minus 3 to 0, we get y equals 3. And when we equate y minus 7 to 0, we get y equals 7. So now we plug in the y values into x equals 12 minus 2y to get their corresponding x values. For y equals 3, we have x equals 12 minus 2 times 3, which is equal to 6. And for y equals 7, we have x equals 12 minus 2 times 7, which is equal to negative 2. Expand and simplify. 2x minus 3 times x plus 6 times x minus 4. When we expand 2x minus 3 times x plus 6, 2x times x is 2x squared. 2x times 6 is 12x. Minus 3 times x is minus 3x. Minus 3 times 6 is minus 18. When we group like terms, 12x minus 3x is 9x. When we expand these brackets, 2x squared times x is 2x cubed. 2x squared times negative 4 is negative 8x squared. 9x times x is 9x squared. 9x times negative 4 is negative 36x. Minus 18 times x is minus 18x. Minus 18 times minus 4 is 72. When we group like terms, minus 8x squared plus 9x squared is x squared. Minus 36x minus 18x is minus 54x. So we have 2x cubed plus x squared minus 54x plus 72. In triangle PQR, M lies on QR and S lies on PR. Explain given reasons why triangle PMR is similar to triangle MSR. Angle PMR, which is 90 degrees, is equal to angle MSR. The two triangles share a common angle, so angle MRP is equal to angle MRS. If two angles in both triangles are equal, then automatically angle MPR is equal to angle SMR. Since all the angles in both triangles are equal, then the two triangles are similar. Triangle ABC is similar to triangle PQR. Find the value of x. For similar shapes, the ratio of their corresponding sides are equal. So we have x over 4.5 centimeters equals 9.9 centimeters over 8.1 centimeters. When we make x the subject, this is what we get, which is equal to 5.5 centimeters. The area of triangle PQR is 25 centimeters squared. Calculate the area of triangle ABC. For similar shapes, the ratio of their areas is equal to the square of the ratio of their corresponding sides. So we have the area of triangle ABC over 25 centimeters squared equals 8.1 centimeters over 9.9 centimeters squared. When we make the area of triangle ABC the subject, this is what we get. When we type this into the calculator, we get 16.7 centimeters squared rounded to 3 significant figures. Find all the positive integers which satisfy the inequality. 3n minus 8 is greater than 5n minus 15. When we group like terms, this is what we get. 3n minus 5n is negative 2n, and 8 minus 15 is negative 7. When we divide both sides by negative 2, we get n is less than 3.5. Notice that we flipped the inequality symbol since we divided both sides by a negative number. The positive integers less than 3.5 are 1, 2, and 3. The region marked R is defined by 3 inequalities. Find these 3 inequalities. Region R is below this line, so we can define this region as 10y plus 8x is less than and equal to 80. The boundary is a solid line, so we attach an equal sign to the inequality symbol. Region R is above or to the right of this line, so we can define this region as x is greater than 4. The boundary is a broken line, so we do not attach an equal sign to the inequality symbol. Region R is above this line, so we can define this region as 2y is greater than x minus 4. The boundary is a broken line, so we do not attach an equal sign to the inequality symbol. Write down the largest value of 3x plus y in the region R for integers x and y. After testing the different sets of integers in region R, the set that gives us the largest value for 3x plus y is 7, 2. This gives us 3 times 7 plus 2, which is equal to 23. A rectangular sheet of paper ABCD is made into an open cylinder with the edge AB meeting the edge DC. AD is 28 centimeters and AB is 20 centimeters. Show that the radius of the cylinder is 4.46 centimeters. Correct to 3 significant figures. We know the circumference of the circular ends of the cylinder and we want to find R, which we can get using the formula of a circle. When we make R the subject, this is what we get. The circumference C is 28 centimeters. When we type this into the calculator, this is what we get, which is approximately 4.46 centimeters, rounded to 3 significant figures. Calculate the volume of the cylinder. Here is the formula for the volume of a cylinder. The radius R is 4.46 centimeters and the height H is 20 centimeters. When we type this into the calculator, we get 1250 centimeters cubed, rounded to 3 significant figures. N is a point on the base of the cylinder such that BN is a diameter. Calculate the angle between AN and the base of the cylinder. On the diagram, we've labeled this angle as theta. The height is 20 centimeters and the base is 2 times the radius, which is 4.46 centimeters. So we have 8.92 centimeters. To get theta, we apply SOHCAHTOA. This gives us tan theta equals 20 centimeters divided by 8.92 centimeters. When we make theta the subject, this is what we get. When we type this into the calculator, we get 66.0 degrees, rounded to 1 decimal place. The volume of a solid cone is 310 centimeters cubed. The height of the cone is twice the radius of its base. Calculate the slant height of the cone. From the illustration, we see that we can get the slant height L of the cone by applying the Pythagoras theorem. But first, we need to find the values of R and H. Here is the formula for the volume of a cone. We've been given the volume to be 310 centimeters cubed. The radius is R and the height is 2 times R. 1 over 3 pi r squared times 2r gives us 2 pi r cubed over 3. When we divide both sides by 2 pi over 3, this is what we get. And when we take cube root of both sides, this is what we have, which is equal to 5.2897. Now that we have the value of R, H equals 2 times 5.2897, which is equal to 10.5794. So now by applying the Pythagoras theorem, we have L squared equals 5.2897 squared plus 10.5794 squared. When we make L the subject, this is what we get. When we type this into the calculator, we get 11.8 centimeters, rounded to 3 significant figures. A curve has equation y equals x cubed minus kx squared plus 1. When x is 2, the gradient of the curve is 6. Show that k equals 1.5. When we differentiate the equation of the curve, we get dy dx equals 3x squared minus 2kx. We are told when x equals 2, the gradient of the curve is 6. So we have 6 equals 3 times 2 squared minus 2k times 2. 3 times 2 squared is 12. Minus 2k times 2 is minus 4k. When we group like terms, we get 4k equals 6. And when we divide both sides by 4, we get k equals 1.5. Find the coordinates of the two stationary points of y equals x cubed minus 1.5x squared plus 1. You must show all your working. At a stationary point, dy dx equals 0. When we differentiate the equation of the curve, we get dy dx equals 3x squared minus 3x. So we equate 3x squared minus 3x to 0. When we factor out 3x, we are left with x minus 1. When we equate 3x to 0, we get x equals 0. And when we equate x minus 1 to 0, we get x equals 1. Now that we have the x values of the stationary points, we plug in these values into the equation of the curve to get their corresponding y values. So for x equals 0, we have y equals 0 cubed minus 1.5 times 0 squared plus 1, which is equal to 1. And for x equals 1, we have y equals 1 cubed minus 1.5 times 1 squared plus 1, which is equal to 0.5. So the coordinates of the stationary points are 0, 1, and 1, 0.5. Sketch the curve y equals x cubed minus 1.5x squared plus 1. From the previous question, we found the coordinates of the stationary points to be 0, 1, and 1, 0.5. To be able to sketch the curve with these points, we need to determine the nature of these stationary points. To do this, we first need to obtain the second derivative of the curve by differentiating dy dx, which is 3x squared minus 3x. This gives us 6x minus 3. For the stationary point 0, 1, its x value is 0. When we plug in x equals 0 into the second derivative, we have 6 times 0 minus 3, which is equal to negative 3. Since this result is negative, it means the stationary point 0, 1 is a maximum. For the stationary point 1, 0.5, its x value is 1. When we plug in x equals 1 into the second derivative, we have 6 times 1 minus 3, which is equal to 3. Since this result is positive, it means the stationary point 1, 0.5 is a minimum. So on the grid, we plot the stationary points and draw a smooth line through the points such that 0, 1 is a maximum and 1, 0.5 is a minimum. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.